Hi, my name is Imani Goffney. I am an assistant professor of math education at the University of Maryland at College Park. I'm also an executive director fellow for the Advanced Education Research and Development Fund. The title of my talk is From Oakland to Wakanda, Transforming Mathematics Classrooms to Become Equitable and Empowering Spaces for Black and Brown Students. So today we'll spend a little bit of time toggling back and forth between a Wakandan context and a U.S. American context. So we'll start by figuring out why we're using Wakanda as a context. Then we'll get to learn from a little boy named Vershawn, who's a part of the EML summer program. Then we'll go back to Wakanda and do some imagining about the system. And we'll do some pedagogical imagining to think about what mathematics teachers might be thinking about and doing and what their work is in the Wakandan education system. And then we'll end with kind of 4 ideas and strategies for how we might promote Wakandan pedagogy in a US context. And we'll end with kind of a call to action and some things that you can kind of consider for yourself. So let's start by visiting Wakanda, right? So Wakanda is the primary context for one of the newer Marvel movies, Black Panther. The fictional kingdom of Wakanda is a small nation in East Africa. It's the richest, most powerful, and most technologically advanced nation on the planet because years ago, a meteorite fell that has vibranium, and it crashed in Wakanda, and that's the only place on Earth where it is. And it's incredibly valuable and very rich, right? Now, when Black Panther came out, at the time of its release, it set so many records at the box office. It made more than $200 million just in the opening weekend. It's the highest grossing film directed by a Black director. It's made over $1.35 billion globally. It was the only kind of superhero movie that was nominated for Academy Awards. It won 3 of them. And at the time, before Endgame and Infinity War and all of those things, it was the highest grossing Marvel film ever. But it's important to kind of consider why that might be the case and why it was so important. So why Wakanda? We were so excited about this movie because we're tired of seeing our people portrayed as drug addicts, violent, confrontational, stupid, poor, aggressive, slaves, prisoners, ghetto. Right? That matters. So this is a picture of my family at Thanksgiving a few years ago, pre-COVID. And so one of the things that our family likes to do, one of our traditions, is that we like to go to the movies in the evening. So you can imagine, when was the last time you think my family got to see a movie, right, where we were represented as beautiful and strong and amazing and thriving? Not because we overcame like colonization and all these other things, but just because Black people vibing and just thriving in life, right? It's one of the reasons that this movie was so popular and so powerful. And so I think that there are things that we can learn. So why Wakanda? What can we learn from Wakanda to create classrooms that provide equity, access, power, and agency for all learners? Wakanda is a place where humanity, integrity, family, culture, language, and tradition are valued simultaneously alongside innovation, technology, math, science, and engineering. So you could pause and think, are our math classrooms right now places where Black and brown kids get to experience humanity, integrity, where their culture and their family and traditions are valued, centered, a part of the mathematical community, right? We know from research that that's not the case. One of the things that I'm suggesting that we could learn is to think about there are certain pillars of that. So vibranium in Wakanda is not used to create weapons for controlling each other or trying to exert power. Instead, it's used to power their cities and to create tools that are shared and improve their whole community. And they're used to help everyone, right? In Wakanda, power and privilege operate in a more global way. There's a council that is used that has representations from all of the tribes that get to have a voice and a say in decision making. They have significant concern for oppressed people, right? And they use vibranium in many different strategies to work in the interest of justice and on behalf of oppressed people. And they also get to travel without assimilating. One of my favorite scenes in the movie is when one of the characters, that's the Dora Milaje, who's a warrior, goes to another place and they shave their heads, but she had to put on a wig. And she was really frustrated about having to put on this wig. And she was frustrated because she knew that she was beautiful and amazing and powerful just because she was. And she didn't want to have to change that for somebody else to respect her. But what about here? How many Black and brown kids feel like they have to change who they are to be able to be seen as valuable and important in our mathematics classrooms, right? So we're going to be thinking about what we can learn from the context of Wakanda to kind of reimagine math teaching and learning. Part of what this entire event is trying to do is to think about how we can improve the quality of math teaching and learning and students' opportunities for academic success. And so one of the things I'm proposing is not that we make incremental changes, but that we need to fundamentally reimagine and transform the way that we approach this work. Now we're going to kind of shift to a US context for a second. How do we think about teaching in US schools, right? Most of our language, and I am speaking to all of the researchers, the policymakers, the teacher educators, the school leaders, kind of everybody. It's primarily a kind of deficit-based orientation, focusing on what students don't know. We use really narrow notions of kind of proficiency, especially in STEM, and control is important, even though we like to call it classroom management, right? There's tracking, there's punishment mechanisms. It's kind of flows through a whole school system. But what if instead we considered the following idea? This is a way that I've described it to my teacher candidates in my method class. What if you thought that a core purpose and challenge for all mathematics teachers and teacher educators and even school leaders was to define their work as learning to see and contribute to the development of the brilliance of Black and brown children? What might that involve? If you don't think that your job is to figure out what they don't know and teach them that, but instead that every single kid is smart and you've got to figure out all the different ways that they're smart and connect that to your mathematical goals. How does that then change the way that we think about teaching? I'm going to come back to this in a second, but right now we're going to get to learn from a little boy named Vershawn. So Vershawn is a part of the EML summer program, and it is important for me to kind of acknowledge that this video and this segment and this kind of teaching and the context was developed by my mentor and colleague, Dr. Deborah Lowenberg-Ball at the University of Michigan, and Dr. Blake Noel now, who developed this strand. So, but it fits right in my Wakanda talk, and they let me borrow it. So one thing that you need to know for you to be able to see and understand what Vershawn is doing, you've got to understand the mathematical context that he's working in. They are working with something called the mini computer. The mini computer is an abstract mathematical context for working on number relationships, mathematical structure, arithmetic properties. It's a setting for developing skills for mathematical argument, analysis, as well as proof. And it offers a novel and complex mathematical environment for children. This is the way that it works. The yellow and the red are called checkers, and there's no difference in value between the yellow and the red. The number of checkers that are on different parts of the square represent increments of that value. So if there are two yellow checkers on the 8 on the brown square, then that is the number 16. The white checker is a negative checker. So it operates the same way when you put it on there. It's a negative increment of that number. So there's a couple of examples, and we can't use animation, so we'll just kind of go through them, right? So on the middle square, you'll notice the one that has the yellow and the blue square, right? So you think about what's the value of that one, right? So most teachers will say 8 plus 4 is 12. I add 2 more for the 2 white checkers that are on the 1 square, and I get 14, but there's then a negative 1 on the 2, so I subtract 2 and I get it 12, right? Other people say the red and the white kind of cancel each other out, so then it's just 12. If you look at the one in the top corner, there's a teachers will usually say, I calculate this by saying 1, 2 for the white square plus 2, so that's 4, and then that's a -8, so then I end up with -4. So that's kind of how the mini computer works. So we're going to get to see Vershawn. Vershawn is a 10-year-old boy. He's Black and he's male. We are seeing him after he's done with 4th grade and he's moving into 5th grade. And he was often sent out of the room to the hall of the principal's office. He got in trouble a lot, wasn't necessarily doing well in math, but he was articulate and he said he liked to write, right? So when you see Vershawn for the first time, we're going to look at Vershawn and we see him between 11:19 and 11:25 of this particular lesson, right? And you can see that in the bigger square, Vershawn is the boy in the black hoodie next to the girl in the yellow kind of jacket. And it's hard to see him, so that's blown up. And so he has something in his hands, and you can see on the bigger image that he's looking down. It's hard to see what it is, but what we're going to tell you is that that's a paper airplane. Vershawn has made and has a paper airplane, right? You see in the bottom square that he also has a brush. And in case you don't know, he has the brush because unlike other people who do their hair once a day, he needs to brush his hair like throughout the day because that's how you get the waves. I have a brother 2 years older than me. He brushed his hair like I feel like my whole childhood. So here's the paper airplane. The teacher's clearly teaching a lesson. I typically ask people, what do we think happens to the paper airplane? Everybody agrees the paper airplane has to go. It's going to be confiscated. It's going to be recycled. It's going to be destroyed. But there's no version of this where Vershawn gets to keep the paper airplane. When I prod them and ask why, they say, because it could go flying. Now, I will say it is a paper airplane. It doesn't have any weapons on it. But teachers are often concerned about the danger that comes with a flying paper airplane in the classroom. So we're going to see what happens in this situation. At 11:26, the teacher says, you know what, Vershawn, I'm going to need you to come up here closer where I can see and hear and you won't be distracted. And so Vershawn moves to the front of the classroom. And then within a minute, he's raising his hand to answer questions. At 11:27, the teacher says, Vershawn, you get to come up here and make a number because you're the closest person to the board. You can have 2 checkers and you can put them wherever you want, make a number, and then you can call on somebody. So Vershawn goes to the front of the board, the front of the class, and he makes a number and he's giving his mathematical explanation and he's using something as a pointer to support him in his explanation. He's using the paper airplane. As math teachers, we only get so many big asks of students and we throw away our asks all the time on things that don't matter, like you're not wearing a belt and that's out of dress code, or you're supposed to only be sitting in your seat, or you made a paper airplane, so now I'm taking it and there might be a discipline consequence. And when we do that, the kid shuts down. They're no longer invested in trying to learn what you're trying to teach them. We throw away our big asks, but what's possible if we don't? What's possible if we don't think that we need to control and police the movements of kids every day is Vershawn can use his paper airplane as a pointer, and it supports him with offering a great mathematical explanation that's a contribution to the mathematical community. But it even pays off even more later. Next, they're working on the 2-checker problem. The 2-checker problem says what numbers are possible to make on the mini computer with exactly 2 positive checkers, right? And so this children figure out that they can't, they found that 7, 11, 13, 14, 15 are impossible with exactly 2 checkers. So an extension is offered. Can you make 7, 11, 13, 14, and 15 if you have a negative checker? You must use both positive checkers and you can use 1 negative checker if you find it useful. So this is what happens 1 week later. And this is a video of Vershawn giving an explanation.
Can you explain how you proved it? Can you come up? Talk clearly to the class, please.
Because
everyone give Vershawn your attention, please.
Because 8 plus 8 equals 16, then you don't have, then the purple is a 4, the red is a 2, and the white is a 1, so you couldn't do it without without another negative number.
Why?
Because
Talk to the class, please.
Because
So you have 16, and what is it you need now?
you need subtract 3.
Okay, and why can't you do that with one negative checker?
Because this is a 4, this is a 2, and this is a 1.
So what did you conclude from that? What did you decide?
But if you had another negative number, you could have had it because you could have put 1 on the red and 1 on the white.
Can someone explain what Vershawn just showed? Why is 11 impossible? Can someone explain his proof? How did Vershawn try to prove it? Vershawn, listen and see if they understand your proof. How did he try to prove it? Zion.
I think what you did was you tried all the ways to do it. None of them matched with 11 because you tried, like the problem said.
Is he trying to make 11 or 13 right now, Zion?
13.
13, okay.
13. Yeah, it didn't match up to 13. He said he tried all the ways. It said you only have 2 positive checkers and you have to use those, and only 1 negative checker that can only be used if it's needed. So really, he tried all those ways to use them and it didn't work.
Vershawn, did Zion repeat your proof right, or do you have anything to change about what he said?
He proved it right.
Okay, do you want to hear one more person say it?
Sure.
Okay, who else would like to say how Vershawn tried to prove that 13 is impossible? Can someone else explain it besides Zion?
What you tried to do was try to put 2 on 8 and try to go up 1 more and then make 13.
Vershawn, is that what you said?
Yeah. Say it again. I don't really hear all of it.
Say it again.
Say it a little louder. Yes. You tried to put 2 on 8 and add up 1 more, but you couldn't because you didn't have a 3rd checker. So you tried to put 2 on 8 and 1 on negative 1 on 1, and it didn't work. And you tried all of it, and it didn't work, and you couldn't make 1 and make 13.
Can you say one more time what you said to the class? Say it one more time clearly, Vershawn. You put 2 on the 8 and then what?
You put 2 on the 8, so that equals 16. Then you can try to see 16 minus 4 equals 12, so that's not right. Then 16 minus 2 equals 14, so that ain't right. Then 16 minus 1 equals 15, that ain't right.
Cassie?
So
Sorry. Go ahead.
So you will need another negative number. So another negative checker. So you can put 1 on the 2, and 1 on the 1.
And what would that give you then?
That would equal 13.
So that afternoon, when Vershawn was writing in his notebook, he wrote, "I think the negative checker is awesome." So what kind of happened in this environment with Vershawn, right? With Vershawn? What was the work of the teacher with seeing Vershawn and assuming his brilliance, right? The teacher trusted Vershawn to be mathematically engaged. The teacher made explicit positive mathematical roles that supported him. Like, he got to be the teacher. He got to choose numerical examples and take feedback from from the students in the mathematical community, which created opportunities to practice mathematics, right? He had an opportunity to do ambitious math by developing agency, by proving the impossible. So focusing on the math as a context for positive roles and identity, because the teacher assumed that Vershawn was brilliant, right? So let's go into our pedagogical imaginations and consider, if we're looking at the classroom, what do we think happens in Wakandan classrooms? Like, what is the teacher doing? What are the students doing? What are they doing together? And what are the policies and structures that support that? I want to offer one kind of cautious point, right? First of all, we need to remember that Wakandan teachers don't use a colorblind approach. They would not use colorblind racism, right? These images are of my 2 daughters, right? My oldest daughter's name is Bria. My youngest daughter's name is Naima. Bria is a little bit more shy, but Naima moves through the world like the living embodiment of Black girl magic. Like it flows through her veins and it sparkles off of her like pixie dust, right? And so when I gave this talk one time, a principal said, I love everything you're saying, but my teachers don't see color. They just see kids. And as a Black woman and as a Black educator and as a Black mom of Black daughters, I paused and I gave a real answer. And I said, how can a teacher be a great teacher for my daughter if she doesn't see her for who she actually is, because she actually is a Black girl, and also how she sees herself? She knows she's a Black girl. She loves being a Black girl. And I said, if we tell the truth, when we say that, what we actually are saying is we just pretend that all the kids are white. My daughter's not white, neither of them. They don't want to be white. They love being Black, right? They find joy and pride and energy in being Black girls navigating the world. So how can one be a good teacher if they don't see my daughter for who she is and for how she sees herself, right? We've got to like hold ourselves accountable for thinking about these things differently, right? So what are the things that we can maybe do to learn from Wakanda as we reimagine classrooms, right? Instead of a deficit approach that's typically used in schools, if we use a Wakandan approach, we are compelled to operationalize the assumption that Black and brown children are brilliant. If we do that, how does that shift or change the questions we ask, the tasks we assign, how we structure classrooms, how students are grouped for learning, how students' brilliance is assessed and discussed among teachers and admins and parents and caregivers? How are students positioned in the classroom? Like, it changes everything about how we approach this work. So it's likely that none of you are prepared to teach mathematics with a Wakandan lens, but let's engage in thought experiment about what that would be like. What principles might guide your work as a Wakandan if you're a math teacher or teacher educator, if you happen to be a school leader, if you're a policymaker, if you're a researcher? Like, what knowledge and skills would be useful in this area? So when I think about what principles might guide that work, right? I think that one of the core pillars is an unwavering, unshakable belief in the brilliance of Black and Latinx students and their families and their community. Like an unshakable belief about the brilliance and the strength that those students are bringing to our classrooms. I think that a posture of curiosity as an instructional leader, instead of as the expert that kind of judges and evaluates students' work. And I encourage you to think about, like, what else might that be? When you're thinking about what knowledge and skills are going to be useful in this work, I'll talk about this just in a second. It's like knowledge about different tribal structures, like the different tribes that are in Wakanda, their values, their purposes, their dialects, that also connects to how we think about kids. Who are they? Where are they from? How can we use that to contextualize their learning, right? We also need skills with identifying and naming the different types of brilliance that students bring to learning and doing math in authentic and nuanced ways. Not just, good job, Jerome, right? But like, hey, that example that you made where you connected this lesson to a thing that we have in our school was really helpful for our mathematical community. And you might push yourself to think about, like, what else is there? So now, here are the four kind of things I'm going to kind of close with about how we can kind of do this. One is about developing specialized knowledge, which I'll unpack, countering dominant narratives, I have a sample of kind of nuanced practices, and then organizing classrooms to promote collective mathematical work. So when we think about the specialized knowledge, right? What kind of background knowledge might be needed to produce authentic Wakandan math teaching, right? So we need deep and expanded understanding of math. We also need to be able to comfortably, professionally talk about issues of race, culture, language, and students' identities. To be good at this work, we have to be able to do that. So mathematical knowledge for teaching is an essential resource for producing high quality, culturally relevant math teaching. Also, just remember, it's not high quality if it's not culturally relevant. Those things are not interchangeable. And this is what supports students with ambitious and positive learning opportunities, which will help them become powerful math learners. It's important to also remember that culturally relevant teaching is localized. It's not general. You don't have a group of Black boys and say, I'm going to make all sports examples. That group of Black boys might be gamers. You don't know. It's about finding out who they are so that you can make those kinds of connections. You also want to continue to expand your own understanding and conceptions of math so that you can leverage those expanded ideas about competency and proficiency from students instead of using narrow notions of skill and proficiency, right? When we have a very narrow idea about this, only some kids are going to be good at it. What we have to do is figure out how can we use expanded ways so that we can see all the brilliance. Mathematical knowledge for teaching can also support teachers with understanding math work in broad terms, recognizing multiple ways of thinking about mathematical problems and mathematical work, and also engage in the work that formulate questions that unpack mathematical thinking of someone whose approach is different than one's own. Another part of the strategy is thinking about developing specialized knowledge around race, culture, language, and students' identities. What are the identities of their students? Not what does the paper say, but who do they say they are? What prior experiences do they bring with them to learning in this classroom? What initial strengths and assets do individual students bring with them to learning and doing math in your setting? Remember, all students have brilliance, right? Teachers got to figure out what the nuances of the brilliance are for individual students. And after doing that, right, design tasks and lessons to expand that brilliance, give feedback to ensure that they see their own brilliance, and create classrooms where they see the brilliance in each other, that there's mirrors where students see their brilliance reflected in the class, in the teaching that you're doing, and windows to see it in each other. Also think about what community resources exist that are a part of the lives of your students. What real world connections can deepen students' understanding of the math. I have a group of colleagues that Aaron Turner and Julia Aguirre and Mary Alice Carson that are doing work where they're mathematizing the students' worlds, right? And they're able to help those students develop a deeper understanding of the math by connecting it to their lived experience. Another part is countering dominant narratives, right? Supporting Black children to see their brilliance. The influence of broad environments start early. Discipline disparities for Black students, boys, and students with disabilities are observed as early as pre-K. Black preschoolers are 3.6 times more likely to be suspended than white children. They make up 19% of the school population, 47% of suspensions, right? We're suspending babies that aren't quite potty trained, or we're telling them they don't belong in our classrooms, right? That's part of why we have the problem we have. So we're going to watch a little boy named Aeon and his mom right now, and we're going to see this video where she talks about the work she's doing with him.
Finally, the 3-year-old who is definitely America Strong. It's the moment moving so many. The simple walk to school, the 3-year-old named Aeon wearing his backpack and remembering the words his mother taught him at just 2. What he says to himself over and over again.
I am smart. I am blessed. I can do anything. I am smart. I am blessed. I can do anything. I am smart. I am blessed. I can do anything.
That's his mother, Alyssa, and she and his father, Alpha, have been telling their little boy for some time that he will grow up to be anything he wants to be. This was one of their first lessons more than a year ago.
You say, I am smart.
I'm smart.
I am blessed.
A bus.
I can do anything.
I can.
He'll get there. 1 year later, now 3 years old, declaring this.
I am smart. I am blessed. I can do anything.
So in the video, you got to see Aeon saying, I am smart, I am blessed, I can do anything. So imagine that Aeon is your classroom. What activities, tasks, or assessments might you design that would use that would help Aeon see all the different ways he's authentically smart in math? How will you communicate to Aeon about the different smartnesses he has? And how will you communicate to his parents about the different smartnesses he has and how he can develop even more? When you think about preparing schools, right? How might you organize schools and classrooms to better support Black and Latinx children and children experiencing poverty thrive in learning? What practices should you focus on improving in your own work to help Black and Latinx and Indigenous students have ambitious and positive learning opportunities? If you happen to be a policymaker or do research, what language will you use to describe Aeon and his community? What impact does that language have on countering dominant narratives? What recommendations will you offer or advocate? What evidence will you use to inform your research and your policy? Also, with member checking, if you didn't talk to Aon or his parents, then you might be reproducing harm instead of intervening on issues, because neutrality doesn't exist. You're either working to change the system or you're supporting the oppressive system that we have, which we know is causes harm. Here's a sample list of kind of Wakandan mathematics teaching practices, right? We think that Wakandan teachers build positive, productive relationships with students, and they use ambitious tasks. They express high expectations for all students. They encourage and support a diverse array of mathematical competence instead of narrow. They attend to students' emotional, social, emotional needs, and they reimagine classroom management from a focus on discipline and compliance to collective mathematical work. And that's the last part strategy I'm going to talk about. So how can we organize classrooms to support productive mathematical work? When we think about strategies we use in classroom management, right? They're mostly about compliance. They're mostly about sanctions. The impact of these structures and practices, especially for brown students, are violent and horrific and produce what we currently have. But if we think about what might happen in Wakanda, we think it might be different. We think that they might move away from notions of classroom management that are characterized by subjective interpretations of students' actions and desire for tight control and policing in ways that are dehumanizing. Instead of seeing classrooms as belonging to the teacher, what if we see classrooms as the workplace of students designed and oriented for them and the work they should be engaged in collectively? If collective mathematical work is the goal, what needs to be done differently? These ideas are drawn from an analysis and a manuscript that a colleague of mine, Mark Hoover, who's at the University of Michigan, and I worked on for several years that we recently submitted. Another part is using intellectual work as a primary means and arranging the classroom in particular ways. There are also nuanced practices of this work. There are things that teachers need to do in this new classroom organization that will support this, right? Interpreting students' reactions and responses generously and positive, providing opportunities for students to maintain and draw on their personal, cultural, and linguistic assets, positioning students as positive and productive members, and intervening on things that are problematic. So what about you? Think about your own approach to improving math teaching and learning. That's why we're all here for this conference. And I'm going to actually suggest that instead of trying to fix children, what if you consider, does your approach interrogate, critique, or challenge structural oppressions of systemic racism in schools that intentionally or unintentionally disempower Black and Latinx students? Does your approach include components of rehumanizing mathematics? And does Black Girl Magic or Black Boy Joy fit into your approach? If we think that children deserve better, that reimagining and transforming classrooms using a Wakandan lens would be better for our children, what might your role be? We are called to recognize and challenge anti-Black racism across our society in the many ways it shows up, particularly in our schools. We've got to identify that structural oppression and systemic racism in schools. We've got to take a personal responsibility for curriculum we use, including the tasks we select, teaching practices we engage, the classroom environment, both face-to-face and virtually, and the way we advocate and vote as citizens in a democracy, right? So this requires deliberate, simultaneous, and sustained attention. It's not a checklist that can be worked off. It's an ongoing process, right? So think about how you'll start. You're gonna have questions. Think about who you'll ask, how you'll work as an individual in teams and whole groups, and how you'll hold each other accountable, and what you will look to measure the impact of your work as an individual doing this work. This is an individual call to action for you in particular. I want to end with this part that sometimes you might have to encourage yourself. So this is a video of my daughter, my youngest daughter, Naima, the one you saw earlier, and she went fishing, and this is many years ago when she was 6.
Hold with this hand. That's all right. It'll swim. Now you go. There you go. Hold on. There you go. Now you got it. Hold it up.
Help her hold that pole up, Mom. There you go, baby.
Come on.
Good job, Naima.
You got it.
And this one's I've got.
That's it. Stop reeling.
Yes!
Stop reeling.
Get it!
Naima, calm down, baby.
Yeah! Booyah, me! Booyah!
Here, Naima.
Look at that fish,
As big as you are.
So as you saw in the video, right, Naima did successfully catch the fish. And so when I'm watching the video and I asked her, why did you say booyah me? She told me, Mommy, sometimes you have to encourage yourself. This work that we're doing is hard. It's really hard and it's ambitious, right? And sometimes you might have to encourage yourself because it is going to be challenging. But teaching can be powerful and it can be a force for justice. We just don't leverage it well. Humanizing work in equity and justice must be deliberate and purposeful. It won't happen on accident. It's challenging but necessary. We can't produce the same kind of teaching and research and expect different outcomes, especially after COVID-19. Our children deserve Wakandan approaches and strategies, and it just might be the transformational change we're hoping for. Thank you. Thank you. Thank you for coming. Are there any questions or even other kinds of, maybe they're not questions, other kinds of responses or commentary that people want to offer? There's a question about the using a traditional curriculum. One of the ways that I try to push myself is to think about, we're not going to be able to control every single thing. And so districts spend millions of dollars on curriculum. So it may not be about having the opportunity to choose the curriculum that you use, but it will be important to think about how you might modify it, right? Like when you're thinking about the curriculum, that the examples, the sequencing of questions, the sequencing of real world examples, the way you unpack things, the way that you assign other things, it's important to know who the students are so that you can make changes as you modify them based on what you know about the students and the mathematical tasks. Yes, I agree that it would be great to think about ways of centering other students of color kind of in these. I will say I'm kind of working on an Into the Spider-Verse example that would be like a Wakanda talk that would get the Miles Morales and his biracial identity in there. So I'm kind of working on that. Thinking about the shift towards mathematical work as a community and how it influences the nature of math teaching. I was actually thinking about this similarly, but a little bit in differently, in that part of the reason that we have, like, one of the consequences for underachievement of math ed is actually stifling innovation in STEM fields, right? So our lack of innovations in this area and our lack of being able to connect it to real world things are also a part of creating issues with national defense, because we don't have enough people that can go into cybersecurity and other kinds of stifling innovation. So I think that figuring out how we can use math and apply it to students' lived experiences as a way of encouraging to think innovatively for being able to solve the next set of challenges that come. That work is only possible if we do these kinds of things where all students, especially Black and Brown students, see their mathematical brilliance and think that school is a place to expand on that instead of stifle it.